Good evening, students. Today we'll study about the logarithmic differentiation for class 12th mathematics. So we have discussed lot of things in this differentiation. Now we'll discuss about the logarithmic differentiation. That is logarithmic differentiation. Let me give you some brief about this, and afterwards we'll try we'll try to evaluate numericals based on this logarithmic differentiation. Okay, so we have about this, we have some formulas. That is log a into b is equal to log a plus log b. Log a upon b we can write as log of a minus log of b. Okay, so we have these two formulas. We have log of m raised to power n, we have n log of m. Okay, so that is how we implement these formulas in the numericals. Now let us try to evaluate it in the numerical. Okay, let's see. So now let's try to implement them in the numericals. That is, we'll pick questions from the exercise, that is 5.5 from the NCERT, and let us try how we can implement such kind of formulas. Okay, so we have, let's say we have first question, exercise 5.5. I am directly taking questions from the exercise. First question we have cos x, cos 2x, cos 3x. How we can implement? Which is very easy. Let phi is equal to cos x, cos 2x, cos 3x. Now my next step will be taking log on both sides. Taking log on both sides. We have log of y is equal to log of cos x, cos 2x, cos 3x. What we can do here? Log of cos x plus log of cos 2x plus log of cos 3x. Okay, so now we have log of y. What we can do here is just we need to now differentiate. Next step is to differentiate with respect to x. What we got? 1 upon y dy upon dx. Now log of x means 1 upon x, so we have 1 upon cos x into differentiation of cos x minus sin x. Similarly, we have log of cos 2x will be 1 upon cos 2x into differentiation of cos x will be minus sin 2x into 2. Okay, similarly we have 1 upon cos of 3x into minus sin 3x into 3. Okay, so now how we can put here? We can simply put here dy upon dx is equal to y into, here we have minus 10x minus 2 tan 2x minus 3 tan 3x, and here we will put the value of y. Okay, we can put the value of y here, so therefore I got dy upon dx is equal to, what is y here? Cos x, cos 2x, cos 3x we have inside minus 10x, we can take minus sign common, 10x plus 2 tan 2x plus 3 tan 3x. Okay, so that is how we able to differentiate a function using logarithmic, using log. Now let us try this logarithmic differentiation in next question we have. Let us see what we have here. In second question we have, that is in the second question we have, because the second question is, we have x minus 1 x minus 2 upon x minus 3 x minus 4 x minus 5, and we have this in root. So let us see how we will try to solve the root. Okay, let y is equal to x minus 1 x minus 2 upon x minus 3 x minus 4 x minus 5. Okay, what we can do here, taking log on both sides, what we can do, take log on both sides, we get here. Okay, what we have, that is log y is equal to half of log x minus 1 plus log x minus 2. Now we have minus log x minus 3 plus log x minus 4 plus log x minus 5. Okay, we all know that log a upon b will be log a minus log b. So now what we can do here, okay, let's differentiate it directly. So now what we have, 1 upon y dy upon dx is equal to half of 1 upon x minus 1 into 1 plus 1 upon x minus 2 minus we have 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. We have this. Okay, so now what we can do here, in a very simple way, therefore dy upon dx is equal to y into y by 2 upon, if I take the LCM, it will become more, become complex. Okay, so we can leave this as it is. Okay, so what we have, if I take the LCM here and try to solve, it will become more complex. What we can do, leave it as it is, 1 upon x minus 1 plus 1 upon x minus 2 minus we have here 1 upon x minus 3 minus 1 upon x minus 4 minus 5. Okay, so what we have this. Now what we can do here is y. What is y? Oh my god, it's too much. So now we can put here, what is y here, x minus 1 x minus 2 x minus 3 x minus 4 x minus 5. We have this, and we can put this here as it is, 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 x minus 4 1 upon x minus 5. I know the question arises in everyone's mind, that is, if I take the LCM of this, what will happen? It will become too more complex of that. So avoid that complication and leave it as it is. So that is how we able to differentiate like this. Now we have the third question here. They have given log x whole की power cos x. Let us try to, let's try to differentiate it using the log. How? Let us see. Consider this. Let y is equal to log of log x raised power cos x. So we have here what we will do, taking log on both sides, we get. Okay, so what will happen? Log of y is equal to cos x log of log x. So how will differentiate? By using the product rule, we'll try to differentiate it. Okay, let's try. Let us erase this question. Now we have the third question here, so we'll try to differentiate it. How? Let us see. We have 1 upon y dy upon dx is equal to cos x into differentiation of log x. It will be 1 upon log x, and differentiation of log x will be 1 upon x. Plus we have, now leave this, differentiation of cos x will be minus sin x. So we can, I am writing it directly, minus sin x we have, that is cos x log of log x. Okay, we have this. Now what is left is cos x upon x of log x. Now we have minus sin x cos x log of log x. Okay, so we have used that. We have first differentiate this, then leaving this we have differentiate this. Okay, so we have log. So what we have here is this one. Okay, so now we can write, therefore dy upon dx is equal to y into cos of x log x minus sin x log of log x. So now what is y here? We have log of x, we have the cos x into cos x x of log x, we have minus sin x log of log x. Okay, so that is how we try to differentiate. Let us try to solve another numerical. Now we have the fourth question. Let us try to solve how we can solve it. We have just tried to solve only, we have solved 3 numericals. If you have any doubt, you can ask. Okay, I hope it's clear to you. Now we have the fourth question here, that is x raised power x minus 2 raised power sin x. Okay, so let us try to differentiate it using log. How we can do it? My first step is, let y is equal to x raised power x minus 2 raised power sin x. So we take log, but we have to write it first. What? Taking log on both sides, we get log of y is equal to log of x raised power x minus log of 2 sin x. Okay, so we can write this as x log x minus sin x log 2. Okay, so now let's start to differentiate it. We know the log x differentiation will be 1 upon x. So we have here y. So we have 1 upon y dy upon dx is equal to, we'll use a product rule. X into differentiation of log x will be 1 upon x plus log x into differentiation of x will be 1. So we have log x minus, we know log 2 is constant, we'll differentiate it. So we got log of 2 cos x. Differentiation of sin x will be cos x. So what do we have here? Now, therefore, dy upon dx is equal to y into log of x minus log of 2 cos x. Y. So what is y here? We have y this. X is power x minus 2 raised power sin x into log x minus log of 2 cos x. Okay. Further we can multiply inside if I got this. Okay. So we can write, if you multiply what you got here, that is x is power x log x minus x is power x log of 2 cos x minus 2 raised power sin x log x plus we have 2 raised power sin x log of 2 cos x. Okay, so that is how we able to differentiate. Now let's try to solve the fifth one now. What the question we have, let us see. We have the question, that is fifth question I have. What the question is, says x plus 3 whole square x plus 4 whole cube x plus 5 whole 4. Okay, so this is what the question we have. Now let us try to solve using logarithmic. Let y is equal to x plus 3 whole square x plus 4 whole cube x plus 5 whole 4. Okay, so we have, that is taking log on both sides. We have, what we get here, very simple way, log of y is equal to log of x plus 3 whole square dot x plus 4 whole cube x plus 5 whole 4. We have this. Now what we can do, log of x plus 3 whole square plus log of x plus 4 whole cube plus log of x plus 5 whole 4. We are using the formula for log a into b is equal to log a plus log b. Here we have 3 abc. So log of abc will be log a plus log b plus log c. Okay, so like this we can do it. Let's try to differentiate it with respect to x. So what we have, 1 upon y dy upon dx is equal to, what we can do here, 2 into log of x plus 3. Okay, we can write this as, so the, okay, then what will happen if I 2 into differentiation of this will be 1 upon x plus 3 plus 3 into 1 upon x plus 4 plus 4 upon x plus 5, because we know the differentiation of log x will be, log x will be 1 upon x. So we have this. So now we can take, therefore dy upon dx will become y into 2 upon x plus 3 plus 3 upon x plus 4 plus 4 upon x plus 5. What we can do here, y, we have x plus 3 whole square x plus 4 whole cube x plus 5 whole 4 into 2 upon x plus 3 plus 3 upon x plus 4 plus 4 upon x plus 5. Okay, so that is how we able to differentiate using the log. Now let's try to solve sixth one. I have x plus 1 upon x whole x plus we have x plus 1 upon x. Okay, now let us see how we can solve this in a very easy way. Let's consider, let y is equal to x plus 1 upon x plus we have x is power x plus 1 upon x. Okay, so what we can do, next step is take log on both sides. Okay, what we can do here, taking log on both sides, we get log of y is equal to x into x. Okay, no, before we need to write this, we have log of x plus 1 upon x whole x plus log of x is power x plus 1 upon x. Okay, now what will be my next step? So my next step will be, that is, we can do it, differentiate it. Differentiating with respect to x. What we got here? 1 upon y, dy upon dx is equal to x into log of x plus 1 upon x. Okay, we have plus, we can say x plus 1 upon x into log x. Okay, now we'll differentiate it. So we got x up x into differentiation of this, we got 1 upon plus, take this and we have differentiation of x will be 1. Next step is differentiate this. Leave this as we'll use our product rule here. Into differentiation log x will be 1 upon x plus log x into differentiation of this will be 1 plus we have, so it will be, if I take this minus 1, so we'll have, that is minus 1 upon x square. So we have this. Okay, so what we can do, what is my next step will be, therefore dy upon dx is equal to y into x upon x plus 1 upon x. Okay, x upon plus we have log of x plus 1 upon x plus we have this, if I multiply this I got 1 plus 1 upon x square plus log x, we have 1 minus 1 upon x square. So now we have, what is y? If you say what is y here, y we have taken this, so we can put this here, x plus 1 upon x whole x plus x plus 1 upon x. No. We have this x is power x plus 1 upon x. Okay. So now we have this. So we have this x upon x plus 1 upon x plus log of x plus 1 upon x plus 1 plus 1 upon x square plus we have log x 1 minus 1 upon x square. Okay, so we have this. So now what we can do here, we can multiply also if we need to multiply it, or we can leave this as it is. Okay, so that's how we are able to differentiate function using log. Now next step will be, we can directly multiply it, x plus 1 upon x whole x, it will be x upon x plus 1 upon x plus we have log of x plus 1 upon x plus 1 plus 1 upon x square we have plus log x 1 minus upon x square. So we have this. Now we can multiply inside 1x. We have x upon x plus 1 upon x plus log of x plus 1 upon x plus 1 plus 1 upon x square we have, plus we have log of x 1 minus 1 upon x square. So that is how we are able to differentiate. Now let's try to solve the another numerical. Now let's try to solve another question we have. That is the seventh one. We have just solved only 6. Now we'll try to solve the seventh. So what the seventh question is, let us try. The question says log x whole raised power x plus x raised power log x. Okay, so we have this. Now how we'll try to solve? We know the first step is, let us consider that y is equal to log of x whole x plus we have x raised power log x. Now taking log on both sides, taking log on both sides, we have, that is log of y is equal to log of log x is power x plus x is power, here also we'll take, that is log of x is power log x, but we can do x of log x plus we have log x into log x, we have log y. Okay, now let's try to differentiate it. We got 1 upon y dy upon dx is equal to x. We'll use here product rule. So x into log x differentiation 1 upon log x into, we have log x into 1 upon x plus limit and differentiation of x will be 1. So we have log of log x. Here also will apply that same thing. Log x into differentiation of log x will be log x upon x plus that log x, it will be log x upon x we have. Okay, so now we have 1 upon log x plus we have log of log x plus x, log x plus log x. Okay, so now we can write here dy upon dx is equal to y into, that is y into, we have here 1 upon log x plus log of log x plus 2 upon x log x we have. Okay, so now we can put a value of y. What is y? We have log of x is power x plus x is power log x, and we'll add this 1 upon log x plus we have log of log x plus 2 upon x log x. Okay, so that is what we have here. Now we can write this in next step, that is log of x is power x minus 1. Okay, into we have 1 plus log of log x. We have here inside, if we multiply with this, we have x is power log of x minus 1 of log x. Okay, so that is how we can easily differentiate the function using logarithmic differentiation. Now let's try to solve 8th one. Now Let us try to solve the 8th question now. We have solved 7. Let's try to solve the 8th. So what we have this 8th question. So now 8th question is we have, that is sin x की power x plus we have sin inverse root x. How will solve it? Let's take it as y. Let y is equal to sin x whole x plus sin inverse root x. Okay, so what we can do here, taking log both sides, taking log both sides. So we have that is log of y is equal to x into log of sin x plus we have log of sin inverse root x. Okay, now let's try to differentiate it. We have differentiating with respect to x. So we have 1 upon y dy upon dx is equal to, differentiate this, x into differentiation of log x will be 1 upon x into differentiation of sin x will be cos x plus differentiation of x will be 1, we have log of sin x plus differentiate this, differentiation of log x will be 1 upon x and we have differentiation of root x, differentiation of sin inverse x root x will be 1 upon 1 minus x square under root. Okay, we have. Now we have this into differentiation of root x. If I say it will be half into we have, that is root x. So we have this now, dy upon dx 1 upon y is equal to x cot x plus log of sin x plus we have sin inverse root x into 1 upon 2 root x 1 minus x. Okay, we have this. So now we can write x cot x plus log of sin x plus 1 upon sin inverse root x into we have x minus, inside we have x square. So now what we can do here, put the value of y there. So therefore dy upon dx, it will be y into x cot x plus log of sin x plus 1 upon sin inverse root x into 1 upon 2 into x minus x square. We have this. Now what we can do here, y into, what is y? Sin x upon x plus sin inverse root x. We have x cot x plus log of sin x plus 1 upon sin inverse root x into 1 upon 2 x minus x square we have. Okay, so that is how we try to differentiate using log. Now next step I can write here, that is sin x power x, we have x cot x plus log of sin x. Okay, this much plus then we multiply with this, so we have plus 1 upon 2 x minus x square we have. Okay, because we have multiplied sin inverse here, it will be reduced, so we have this much. So that's how we try to differentiate it. Okay, so we have. Now let's try to solve another numerical we have. We have just solved 8. Now, well, try to solve next one. So we have this ninth question now. We have just solved 8. We have x raised to power sin x plus sin x raised to power cos x. Okay. I hope now it becomes easier for us to understand about solving the function as using log. Okay, let's try this. Let's take this y is equal to x raised to power sin x plus sin x raised to power cos x. So we have this is equal to taking log on both sides. Taking log on both sides. We get log of y is equal to log of x raised to power sin x plus log of sin x cos x. We can take as sin x log of x plus cos x log of sin x. Okay. Now what we can do here? Differentiate it. 1 upon y dy upon dx. We have product rule here. Sin x into differentiation of log x will be 1 upon x plus log x into differentiation of sin x will be cos x. Similarly here if I put cos x into differentiation of this will be cos x upon sin x into differentiation of sin x will be cos x plus leave this. Okay, cos minus sin x, no? Minus sin x into log of sin x. Okay, so we have this. What we can do here? Now very simple way. Sin x upon x plus cos x log of x plus cos square x upon sin x. Here we have minus sin x log of sin x. Okay. So now what we can do here? Therefore, dy upon dx will be y into sin x upon x. Okay. Plus we have cos x log x plus cos square x upon sin x minus sin x log of sin x. Okay, now what we can do? Put here y. What is y we have? X is power sin x plus we have sin x whole power cos x we have into sin x upon x plus cos x log x plus cos square x upon sin x minus sin x log of sin x. Okay, so we have this. So that is how we can solve the numerical. We have the next step here. What we have, I can multiply here this and find the value here. We have x is power sin x minus 1 plus if I multiply this we have x is power sin x cos x log x plus if I now multiply with this I got sin x cos x minus 1 and we have cos square x minus sin x log of sin x. That's how we can easily solve the numerical here. Okay, so let's try another one. Else what we can do, instead of writing this we can also leave it this as, that is we have x is power sin x plus sin x cos x. We have, no? So we leave it as it is. We have sin x upon x plus cos x log x. We need to simplify it more. Cos upon sin will be cot x into cos x minus sin x log of sin x. Okay. Instead of multiplying this inside, we can leave it as a part after simplifying it more further. Okay. So now we have, let's try to solve the next question we have. Now let's try to solve the 10th question we have. We have just solved 9. So now we'll try to solve the 10th. Okay, so we have 10th question. Now the 10th question says x is power x cos x plus we have x square plus 1 upon x square minus 1. Okay, so we have this question here, x is power x cos x plus x square plus 1 upon x square minus 1. Now let us try to solve using the log. How? Let us see. We have, let y is equal to x is power x cos x plus x square plus 1 upon x square minus 1. Okay, let's try to, taking log both sides. We'll write each and every step taking log on every sides. So what we get here? We get, that is, log of y is equal to log of x is power x cos x plus log of x square plus 1 x square minus 1. See, we can differentiate them separately, taking as u and v, then separate it and then we add and write here. Instead of doing that, what I am doing is I am differentiating both together. Okay, so now what will be the next step? Differentiating with respect to x, we have 1 upon y dy upon dx is equal to f. So we have this, but we can do x cos x log x plus we have this log of x square plus 1 upon x square minus 1. Let's start to differentiate it. Now we have the three functions here, x log x, x cos x log x, and we have this. Okay, so now what we can do here, let's start to differentiate it. Okay, now let's start to differentiate it. So we got 1 upon y dy upon dx. We'll differentiate it them separately. First we'll differentiate x, we got 1 into we have cos x log x. Then differentiate cos x, so we have here minus sin x into log x into x. Now here we'll differentiate log x, so we'll have, that is, x cos x into differential log upon x. So it will be this plus, now differentiate this, what we can do, log x differentiation will be 1 upon x square plus 1 upon x square minus 1. Okay, so now into differentiation of this will be u by v differentiation. So v, that is x square minus 1. Differentiation of this will be 2x minus, now x square plus 1 into 2x. Okay, upon we have this x square minus 1 whole square. Okay, so now we have, that is, cos x log x minus sin x into x of log x. Okay, plus 1 upon x square plus 1 upon x square minus 1. Here we have, if I take 2x common, we have x square minus 1 minus x square minus 1 upon we have minus 1 whole square. So what we will get here? This. Okay, so I got this, that is cos x log x minus sin x into x of log x plus I have 1 upon x square plus 1, x square minus 1, 2x upon x square minus 1, and here we have minus 2 also, so it will be minus 4. Okay, so I got this. Now what I can do here, in a very simple way, we have squared this, no? So now if I try to put this, we have, therefore dy upon dx will be y. What is y? Don't have y, we have y, that is x is power x cos x plus 1 upon x square minus 1. We have inside this, we have cos x log x minus sin x into x log x minus 1 upon plus 1 upon x square minus 1 into 4x upon x square minus 1 whole square. We have this. Okay, so that is how we differentiate it. So we have this left with cos x here. Okay, so here we'll try to put it cos x. So here also we'll try to put inside plus cos x. Okay, so this is how we try to differentiate the function. Now let's try to solve 11th question. We have just solved only 10. So now we have the 11th question. So what we have the 11th question? We have x sin x whole x. We have x sin x whole x plus x cos x 1 upon x. Okay, we have this question. X is for x cos x is for x plus x sin x is for 1 upon x. So how we'll try to solve? Let us see. Let's take it. Let y is equal to x is for sin x whole x plus we have x into cos x whole 1 upon x. So now what we can do here, taking log both sides. Taking log both sides. We have. So what we have? Log of y is equal to, we have log of y is equal to x log of x sin x plus 1 upon x log of x cos x. Okay, so taking log both sides, now we'll try to differentiate it. Okay, let's try to differentiate. Differentiating both sides. Differentiating both sides here. We have, so 1 upon y, y upon dx is equal to x into differentiation of this will be x sin x. Now differentiating this x sin x, x into cos x plus sin x. Okay, so I have this. Now what we can do here, we have x into differentiation of this 1 upon x sin x into differentiation of this cos x plus, now differentiation of x will be 1, so we'll have log of x sin x plus, now we have this. What we can do here, we'll try to implement and we that the product rule I have, so we'll have 1 upon x into 1 upon x cos x into, okay, we have, so now 1 upon x into 1 upon x cos x into differentiation of this will be x minus sin x plus cos x. We have this, and now plus log of x cos x. Differentiation of 1 upon x will be into minus 1 upon x square we have. Okay, so we have this minus this. So we have taken this. Okay, so using the UV product rule we have applied here. So what we can do here, now we have the next step, that is, it will be, if I multiply this inside, I got x cot x plus 1 plus log of x sin x. Okay, plus we have 1 upon x square cos x into, we have minus x sin x plus cos x. Okay, we have this, and we have minus 1 upon x square log x cos x. Okay, so what else we can do here? Now a simple way, x cot x plus 1 plus log of x sin x plus 1 upon, if I multiply inside, what will get are minus 1 upon x sin x, 1 upon x we have, and sin x upon cos x will be 10x. Then we have cos x whole plus 1 upon x square. Okay, and here we have minus 1 upon x square log x cos x. Okay, so now what will be dy upon dx is equal to y into x cot x plus 1 plus log of x sin x minus 10x upon x we have plus 1 upon x square minus 1 upon x square log of x we have cos x. Okay, so now we have this. So now what is the value of y we can put here? X is sin x whole x plus x of cos x 1 upon x. What else we can do here? You can try to implement this right simply as it is what we have solved, plus log x sin x minus 10x upon x plus 1 upon x square minus 1 upon x square log x cos x. Okay, so that's how we try to find log. Using log we can differentiate a function. And now let us try to solve another question we have. 12th question now. We just solved 11. Let's try to solve 12th one. Now we have the 12th question here. That is, we need to find the dy by dx in that. We have x is power y plus y is power x is equal to 1. Okay. So this is a question we have. X is power y plus y is power x is equal to 1. Differentiating, if I, let's try to, what we can do it. Okay. Taking log both sides. Taking log both sides. So what we'll have here? X, y. So we'll have y log x plus x log y is equal to log 1. That it will be 0. So we have now differentiated. Now differentiating with respect to x, we have what we have. We need to differentiate it. So how we can do it? Y into log x 1 upon x plus log x into dy upon dx plus we have x into x upon y into dy upon dx plus we have log y here is equal to 0. Okay, so now what we need to do is we need to find the dy upon dx. Take both that side. So we have log x plus x upon y dy upon dx, and that side we have minus of y upon x plus log y we have. Okay, so now what we can do here, we'll write therefore dy upon dx, it will be minus log y plus y upon x, upon we have log of x plus x upon y. Okay, so we have this. Let's try to find what else we can do here. We have this dy upon dx is equal to this. Now let's try to solve the 13th question we have. So what is the 13th question? Let us see. We have the question is very simple. That is, we have the question here. We'll try to solve this. So we have the question here, that is y raised to power x is equal to x raised to power y. What we can do? Minus x raised to power y is equal to 0. Okay. Now what we can do? Taking log both sides, we have what will happen? Log x log of y minus y log of x is equal to 0 here, because you know taking log of any 0 will be 0. So now what will happen? Differentiate with respect to x. We get x upon y into dy upon dx plus we have log y minus y in upon x, we have minus, because we will take minus sign inside, so we have 1x into log x into dy upon dx is equal to 0. Take this side and that side, so we'll have x upon y minus log x dy upon dx will be y upon x minus log y. Okay, so that we have. What we can do here, we'll take that side, so therefore dy upon dx is equal to y upon x minus log y upon x upon y minus log x. So we have this. Okay, so that is how we try to find the dy upon dx. So now let's try to solve the 14th question we have. So we have the 14th question here. What is the 14th question? Says cos x raised to power y is equal to cos y raised to power x. Okay, that is cos x is for y and cos y is for x. What we can do? Take this side, so we have cos x is for y minus cos y is for x is equal to 0. Now taking log both sides, taking log both sides, we have, that is y log cos x minus x log cos y. Okay, so we have taken the log. Now we'll try to differentiate it. Well, right here, differentiating with respect to x, we have y upon cos x into differentiation of cos x only minus sin x plus log of cos x dy upon dx minus x upon cos y into minus sin y dy upon dx. Okay, we have this, and then we have plus difference, it will be minus, we will say log of cos y is equal to 0, because leaving this, differentiating x with respect to x will be 1. So now what we can do here, we'll do the simply, we'll take that side and we'll leave them dy upon dx. So we have this log of cos x plus x sin y upon cos y dy upon dx is equal to, we have taken that side, so we have log of cos y and it will be plus y tan x. Okay, we can differentiate this. We got log of cos x plus x tan y dy upon dx. Log of cos y plus y tan x. Okay, so now therefore dy upon dx is equal to log of cos y plus y tan x upon log of cos x plus x tan y. Okay, that is how we try to differentiate. That is, we need to find a dy upon dx using log. Now let's try to solve the 15th one. That is, I have xy is equal to e raised power x minus y. What we will do? Taking log on both sides. So we have, that is, log of xy is equal to log of e raised power x minus y. We have log of x plus log of y is equal to e raised power x minus y. Sorry, here we'll put x minus y because log of e will be value 1. So we have this. Now what we can do here, differentiating with respect to x, we get 1 upon x plus 1 upon y dy upon dx is equal to, if I differentiate this, I got 1 minus, okay, we have this, we have taken, so 1 minus dy upon dx. What we can do here, we'll try to take this side, so we have 1 upon y plus 1 dy upon dx is equal to 1 minus 1 upon x. Therefore dy upon dx will be, what will be dy upon dx? It will be 1 upon 1 minus x, 1 plus 1 upon y. Okay, if I try to simplify, I got x minus 1 upon x upon y plus 1 upon y. So we have x minus 1 y plus 1 upon xy. Okay, so that is how we can solve this kind, or we can leave this as it is also instead of differentiating more, because we need to find the dy upon dx. So it will be x minus y into y upon x y plus 1. Okay, that is how we try to differentiate. Now let's try to solve the next question I have. That is 16th question. Now we'll try to solve. So we have the 16th question here. That is, we need to find the derivative of 1 plus x, 1 plus x square, 1 plus x4, 1 plus x8. And after finding the derivative of this, we'll try to find the f dash 1. So how? Let's try to solve this. Let we say that is y is equal to 1 plus x, 1 plus x square, 1 plus x4, 1 plus x8. Okay, so what we'll do, taking log on both sides. So what do we have here? Log of 1 plus x, 1 plus x square, 1 plus x4, 1 plus x8, log of y. We know that log of a, b, c, d will be log a plus log b plus log c plus log t. So we have log a plus log b plus log c plus log of t. So we have this. Now what will be my next step? I will differentiate it. Okay, so let's try differentiating with respect to x. We get that is 1 upon y dy upon dx will be 1 upon x plus 1 upon 1 plus x square. We have 2x plus we have 1 plus x4. We have 4x cube plus I have 8x7 upon 1 plus x8. Okay, so now we have, therefore dy upon dx will be y into 1 upon 1 plus x plus 2x upon 1 plus x square plus 4x cube upon 1 plus x4 plus 8x7 upon 1 plus x8. Okay, so now they want, we need to put this value here, 1 plus x, 1 plus x square, 1 plus x4, 1 plus x8. Here we have 1 plus x plus 2x upon 1 plus x square plus 4x cube, 1 plus x4 plus 8x7 plus x8. Okay, so now what else we can do here? Now we need to find f dash 1. So if I put x1, 1 plus 1, 2, 1 plus 1, 2, 1 plus 1, 2, 1 plus 1, 2, because having 1 any power will give we answer 1. So we have this. So we have here 2 plus 2 upon 2 plus 4 upon 2 plus 8 upon 2. Okay, so what do we have here? 2 to 4 into 2, 16 into we have 2 plus 1 3 plus 4 7 plus 8, 7 plus 15 upon 2, 8. So we have 120 is my answer. Okay, so that is how we find the value of f dash 1. Okay, so now let us try to solve the next question we have. That is, we have one function and we need to differentiate it in 3 ways. So now let's try to do it. So let us try to write the first function we have, x square minus 5x plus 8. We have the question here, x square minus 5x plus 8 into, we have the question here, we have x cube plus 7x plus 9, cube plus 7x plus 9. Okay, so this is the function we have. We have to use 3 ways. First, by using the product rule. Second, by expanding. Third, by logarithmic. Okay, so now what we can do here, we'll expanding the product. Okay, so now what we can do, let's y is equal to x square minus 5x plus 8 x cube plus 7x plus 9 I have. Okay, so now I have, let's try to solve by first by find x. What we can do here, by multiplying by each one, then we try to, by expanding we can say. So we'll have this y is equal to x is power 5, we have 7x cube plus 9x square minus 5x4 minus 35x square minus 45x plus 8x cube plus 56x plus 72. Okay, so now therefore dy upon dx will be 5x4 plus 21x square plus 18x minus 20x cube minus 70x minus 45 plus we have 24x square plus 56. We have this. But we can write here this 5x4 minus 20x cube square 24 plus 21. We have 45x square. Then we have this. So we'll have minus 52x and we have this so we will have plus 11. Okay, so first method we have applied here, that is by expanding the product to find its differentiation. Now the next step will be, this is my first method. I will apply here three methods to differentiate this function and we'll find the answer same in each case. How? Let us see. First case I have. Now I have second case. How? By using the product rule. So we'll first differentiate this. Let y is equal to, we'll consider first x square minus 5x plus 8, x cube plus 7x plus 9. So now we'll differentiate first. We'll keep this and we'll differentiate this. So we'll have 3x square plus 7 plus, now keep this. Okay, and we'll differentiate this. So we'll get 2x minus 5. Now we'll multiply 3x4 minus 15x cube plus 24x square 4x plus now 7x square minus 35x and we have plus 56. Here we'll have 2x4 minus we have 14x square plus 18x minus 5x cube minus 35x, we have minus 45. Okay, so now how? We'll try to solve this. We have, that is 3x4 plus 2x4, 5x4, 15x cube and 5, which will be minus 20x cube. Okay, so next will be after square 24 minus 14, 10. Wait. We have 24x square plus 7, 31x square. Okay, 31x square. Then we have 14x square. Okay, then we have else. So we can say here 24 plus 7, 31. 31 minus 14, 21. So it will be, we have 15x square. We have, okay, let us see. Then we have after square, we have minus 35 minus 70x. We have, no, it will not be minus 35 minus 70. Then we have plus 18 minus 52x. And here we have 56 minus 45. So it will be 11. Okay, so that's how I got here. We have solved this. Here we have some mistake here. We'll try to find 24x square. We have, that is, here if I put this plus 24x square, okay, but here if I put, that is where I have put 24 plus, we have, this is 3x square plus 24. Now we have 7x square. Okay, minus 35x plus 56 plus 2x4 we have, then we have minus, we have here plus 14x square. So now I hope it's clear now. 31 plus 14, it will be 45. So we can see that by applying two methods, here I have applied the product rule. Okay, here I apply the product rule. Here I have first multiply with each member and then I have, after expanding, then I have differentiate. So After applying two methods, I find the answer same. So now the next third method we have to apply that of log. Now let's apply the third method. Okay. Now by using the log we have. So here I think we can do here, that is third, same, that is let y is equal to x square minus 5x plus 8 into x cube plus 7x plus 9. What we'll do? Taking log both sides, we get, that is dy upon dx is equal, first take log. Okay, so log of y is equal to log of, we know that log of ab will be log a plus log b. So we'll have now differentiating. So let's try to solve here. We have this differentiating with respect to x. We get, that is log y, 1 upon y dy upon dx is equal to this log x will be 1 upon x square minus 5x plus 8 into differentiation of this will get 2x minus 5 plus we have 1 upon x cube plus 7x plus 9 will multiply with it, will got 3x square plus 7 here. So I got this dy upon dx, it will be y into this. If I have x square minus 5x plus 8 x cube plus 7x plus 9, will have this 2x minus 5, and here I have x cube plus 7x plus 9 plus 3x square plus 7. Inside I have what? I have inside this one. This will be x square minus 5x plus 8. So now we can solve it. We have y. What is y? We can put here x square minus 5x plus 8. We have x cube plus 7x plus 9 upon, I have this x square minus 5x plus 8 x cube plus 7x plus 9 into, we have this. So we have this. So now what we can do here in a very simple way, multiply this, we get 2x4 plus 14x square plus 18x minus 5x cube, okay, minus 35x minus 45 plus 3x4, it will be reduced, 3x4 I have minus 15x cube plus 24x square plus 7x square minus 35x plus 56. So now if I solve this, I got 5x4, then we have in a cube minus 5 plus minus 20x cube, see same answer is coming, square we have 14x square plus 24, okay, plus 7, 31, same 45x square. If I 18x, we have to see minus 35 minus 70, so minus 52x, and less we have minus 45, it will be same here. Okay, so we can see that after differentiating one function by three methods, product rule I have applied, logarithmic differentiation I have applied, and the third thing I have applied here, by expanding it and after differentiating, I find the answer same. So that is how we try to differentiate a function. Now let's try to solve one more question we have, that is 18th question. Similar question I think I have. Next, we'll try to solve. Okay, so we have, so now let's try to solve. We have given the function that is UVW. Okay, that is UVW. Okay, we need to differentiate it by repeated application of product rule and by logarithmic UVW. Okay, so we have the function that is, let take y is equal to UVW. First we'll apply the logarithmic here. So taking log on both sides. So we have that is, we get here is log of y is equal to log of UVW. So we have log of u plus log of v plus log of w of y. This is the first method I am using, that is logarithmic differentiation. So now differentiating both sides with respect to x, we get 1 upon y dy upon dx. We have 1 upon u. Okay, 1 upon u I have du upon dx plus 1 upon v dv upon dx plus 1 upon w dw upon dx. d upon dx we have done. Okay, so what will happen? Therefore dy upon dx, it will be y into 1 upon u dy dx plus 1 upon v dy dx plus 1 upon w dy dx. So now we have this. So we can put a value of, here if I say UVW, so we have 1 upon u d by dx plus 1 upon v d by dx plus 1 upon w d by dx. Okay, so that is how we have this one method I have applied here, that's a logarithmic differentiation. Now we'll apply the repeated. So we'll have y is equal to UVW. So dy upon dx will be, first we'll differentiate u into d by dx of VW plus, then we have here we'll have v, that is we'll differentiate will no, we can't apply like this. We need to solve this. Let's if I differentiate du upon dx, we have VW plus dv upon dx, we have uw plus dw upon dx, we have uv. Okay, so that is how we able to find the answer will be same. Okay, so that is how we have done. So 1 upon dx. Okay, so we have this uv w here, uv w. If I multiply in this, also I got here vw du by dx plus uw dv by dx plus uv dw by dx. So we can see we have find the answer same by differentiating by two different methods, by logarithmic differentiation and by repeated application of product. So that is how we try to differentiate the function using log. So if you have any doubt, you can ask, share and comment. Please also like my channel.